Hello students, this is a lecture series on computer vision. In this lecture series, I will explain the fundamental concepts of computer vision in an interesting way. My name is Daud Ahmed and I am a computer scientist. I am highly proficient in artificial intelligence, machine learning and computer vision. I have recently graduated from Fast National University in Pakistan with a stellar 3.89 CGPA and an honor of magna cum laude. I am a gold medalist and I graduated at the top of my class. My target audience or my students are anyone from a beginner computer scientist interested in learning computer vision to an expert in computer vision who is looking for novel ideas. So let's head to the next section. I will provide an introduction to the fundamental concepts of computer vision. All the previous courses are very redundant and they have the same concepts related to computer vision. Therefore, I will provide a novel introduction with intricate details. We will mainly focus on deep learning, that is, concepts of neural networks. For example, we will have a look at convolutional neural network or autoencoders, generative adversarial networks, we will have a look at real-world applications of computer vision. For example, we will have a look at how computer vision is useful in medical imaging or in plant disease recognition. Finally, I will provide you several coding challenges that will help you with hands-on skills in computer vision. The convolutional neural network is a fundamental concept in computer vision. It is a type of neural network that captures the spatial aspects of an image. This is what the structure of a convolutional neural network might typically look like. It takes as input an input image and then moves it through a convolutional layer, then to a pooling layer, then to a fully connected layer, and then to an output layer. The input image contains three channels: the red channel, the green channel, and then the blue channel. So it is an RGB image: R for red, G for green, and B for blue. These three channels move to the convolutional layer, which learns different features of the image, such as the texture of the image, the edges in the image, and the shapes in the image. Each of these aspects is learned by different feature maps. The feature maps are represented by the boxes. So there are four feature maps. To reduce the complexity of the feature maps, we use a pooling layer. The pooling layer will shrink the size of the feature maps and will keep important information. The output of the pooling layer is moved to the fully connected layer. The fully connected layer will translate those that information into useful predictions. Finally, the output layer will produce the output of the model. For example, we have an image that contains an animal and we want our output layer to predict whether the animal is a cat or not. So in case the animal is a cat, it should predict a 1, and in case the animal is not a cat, it should predict a 0. So the output layer will produce a probability in the range 0 to 1. If the output layer produces a number greater than 0.5, we can translate it to a cat. And in case it is less than equal to 0.5, we can translate it to no cat. This is the basic picture of a convolutional neural network. These are three example variants of the convolutional neural network. The first one is the traditional convolutional neural network or the CNN. The second one is the residual neural network pronounced as the ResNet. The third one is the densely connected convolutional neural network also called the DenseNet. The input to each network is represented by X and the output is represented by Y. Blue boxes represent layers. The output of the first layer is F and the output of the second layer is G. The problem in the traditional convolutional neural network is that layer 2 is not considering this information. So X is being lost in layer 2. This problem is being solved by ResNet by using this connection. It is called a skip connection. So the output of the residual neural network is the concatenation of f of x and g of f of x represented by this. Densely connected networks called the DenseNet solve this problem in a different way. In this type of network, each layer's input is the concatenation of the output of each of the previous layers as well as the input. So, for layer 2, the input is the concatenation of f of x and x, which is this. Now, the output is then this, which is here. So we will have a look at several other variants of the convolutional neural network as well later in this course in detail.